Algebra 2 Honors 9.2. We're going to be working with angles and radian measures. And so we're going to be drawing angles in standard position, finding coterminal angles, and applying radian measure. So first of all, we're going to look at drawing angles in standard position. And when we have angles in standard position, we're going to be working in a coordinate kind of system where we have an X and Y axes. And so the initial side is always going to be that positive x-axis. So draw a line with an arrow on it, and that is going to be your initial side of your angle. And the other side is going to rotate, and it's going to be called your terminal side. So wherever that ends up is going to be your terminal side. Make sure you have the arrow on it. And that angle is going to be positive if you rotate counterclockwise. The angle is going to be negative if you rotate that terminal side clockwise. And so an angle is in the standard position when its vertex is at the origin, initial side is on the positive x-axis. And then according to which direction you turn, you either get a positive or negative angle. And right now, this is showing that it's going this way. That is counterclockwise. That is going to be a positive angle. So your first problems are going to be asking you to draw angles in standard position. So draw an angle with a given measure in standard position. Well, when I have 390 degrees, that's 360 degrees plus an additional 30 degrees. And so start by putting in the initial side on the positive x-axis. Don't forget the arrow. And then what we're going to do to show that we rotate counterclockwise and more than one full turn is we're going to come around. There's one full turn. Oops. There's one full turn, and I need to go 30 degrees beyond, which is about 1/3 of 90, so about there. And so you show this, you need to show that you are turning a full circle plus an additional, and then we just write 390 degrees. So a negative 160, well, 180 would be half a turn. You're short 20 degrees from a half a turn, but you are going in the clockwise direction. So I'm going to put my positive x-axis for my initial side, and then I'm thinking I'm going to be rotating this direction because it's a negative angle, and I'm going to be 20 degrees short of half of a turn. So about there. And then label this as negative 160 degrees. Don't forget your arrows on your initial and terminal side. Don't forget to draw this saying which direction you're rotating and put the value of the angle by it. So 690, well, I got to break that up and think, well, 360. Another 360 would be 720 degrees. So if I subtract 360 from this, that's going to give me 330 degrees. I'm 30 degrees short of making two full rotations. And it's positive, so I'm going to start with the positive x-axis, and I'm going to go around once, and then I have to go 330 degrees, 30 degrees short from another full rotation, so end up about here. And there is my terminal, and that is a positive, 690 degrees. So that's drawing angles in standard position. Then coterminal angles are angles that share their terminal side. Coterminal angles are angles that share the terminal side. For example, if I came up to this part C in example 1, but I didn't go around twice and I just went around one time to get to that same spot, a coterminal angle with 690 degrees is 330 degrees because they end in the same spot. If I were to go this direction to get there, that would be negative 30 degrees. That angle would be coterminal. So those are two coterminal angles with 690 degrees. So they're angles that end up with their terminal side in exactly the same spot. So to find coterminal angles, you add or subtract multiples of 360. So frequently you'll be asked to give one positive coterminal, give one negative coterminal, and you just need to keep adding 360 till it becomes positive if you start with a negative, or keep subtracting 360 until you end up with a negative if you're trying to get to a negative one. So a coterminal angle is an angle whose terminal side coincides with another angle. So example 2, find one positive and one negative that are coterminal with these. Well, algebraically, you just add 360 to this, and you get 285 degrees. Or you subtract 360, and that gives you a negative 435 degrees. So there is one positive and one negative coterminal. So if I am drawing 75 degrees, it's not 90, but we are rotating clockwise. So there's my angle drawn in standard position. So what's happening with that 285 is you are just ending up going this way. So it's that 360 minus 75, short 75 degrees from 360. However, for the negative 435, you are starting and then going all the way around, plus an additional 75 degrees in the clockwise direction, which is negative. So a negative 360 plus an additional negative 75 gives you that negative 435. And both of those angles will be coterminal. They end in the same spot. They share coterminal sides, or terminal sides. All right, in part B, I have 460, but that's already over a full rotation. So I'm going to subtract 360, and when I do that, I still have a coterminal angle with 460 of 100 degrees. And then I'm going to subtract 2 sets of 360 so that I can get to a negative value. So that's going to be 460 degrees minus 720 degrees. And when I subtract that, I get a negative 260 degrees. So there is my positive and there is a negative. And so the 460 degrees was 100 degrees more than a full rotation. So the 460 is counterclockwise, so it's a full rotation. And then 100 degrees is going to be 10 degrees beyond 90. So there's its terminal side, and that's your 460 degrees. But I can get there to this 100 just by going to the 100 degrees. Or I can get there by going backwards a negative 260 degrees. All three of those angles end up in the same spot. So they are coterminal angles. All right, now those are degrees, but we're going to be working with radian measures. And the radian measure of an angle is measured the measure of the intercepted arc length on a circle of radius 1. So if I have a circle with radius 1, let's see if it'll turn there. We'll say that's my radius 1. So that would mean this right here is at 1, 0. This right here is at 0, 1. This is at negative 1, 0. And this is at 0, negative 1, because this is a circle with a radius of 1 centered at the origin. And the radian measure of the angle is the measure of the arc length when it's on a unit circle. So if I start with the standard position angle, and if I go to here, this angle is equal to the measure of the length of this arc. We won't put units on it. So the circle's arc length will equal the value of the angle in radian measured. Now the angle in radian measured, they're called radians, but there really isn't a unit. It's just, that's what they're called. And so anyways, you're going to need to convert between degrees and radians. So you're going to need to be very familiar with radians and degrees and how they relate to one another. And you're going to be using that half of a turn of a circle is pi radians, approximately 3.14 radians. So 3.14 radians is the equivalent to 180 degrees, approximately. So we're going to work with this. I'm going to try to go through some things that might be helpful in terms of the background on this. And so starting off, if I have this would be the origin, then we're saying that half a turn, 180 degrees, is the same as pi radians. So crazy. 3.14 is your radian measure, but that's 180 degrees. And then we're going to take and split these up. So if I take the circle, and I'm going to take that half a turn and divide it in thirds. So I'll try to make them somewhat equivalent. So I took that half turn and I divide it in thirds. So each of these angles is pi divided by 3. So if I think of this starting with my initial side on the positive x-axis and ending here, this angle is pi thirds, so we're going to equate this is pi thirds, which is going to be the same as what would have been 60 degrees, 180 divided by 3. If I change it up and I'm thinking, okay, still initial side here, but I go all the way to here, I've rotated 2 pi thirds. So that amount of rotation is 2 pi thirds in radians, 2/3 of 3.14. And so that would be 2 sets of 60 or 120 degrees if we were working in degrees. And then if I do a half turn all the way to here, and so I'm ending up over here, that would be 3 pi thirds. You've gone through 3 of those angles. Well, that's the same as pi, which is what we said. Half a turn is pi radians, which is 180 degrees. So pi radians is 180 degrees. You're going to want to know those. And then we could continue and divide the bottom half and continue, and this would be a 4 pi thirds, this would be a 5 pi thirds, and then if we do a full rotation, you get to 6 pi thirds, which is 2 pi. So 2 pi is the equivalent to a full rotation in degrees of 360. So you're going to want to know that, well, 60 degrees beyond 180 is 240 degrees. So 4 pi thirds is 240, 5 pi thirds is another 60 beyond that. It's 300 degrees. Again, it's 60 degrees before you hit a full rotation. And so those are values that you're going to want to just know. You're going to want to know, oh, 4 pi thirds, 240 degrees, 240 degrees, 4 pi thirds. Well, we can continue to divide this, but instead of taking a half a turn and dividing it in thirds, we're going to divide it into 6 congruent pieces. So I'm going to start by, this would be up at 90 degrees. And so 90 degrees, think about dividing that in thirds as best as you can. And then what would be your second quadrant? Think about dividing that in thirds as best as you can as well. So each of these, I've taken 180 degrees. I've taken half a turn, which is pi, divided into 6 equal parts. So this is 1 pi 6. This is 1 pi 6. This is 1, etc., etc., etc. Over here is 1 pi 6 in terms of an angle. All of these are taking half a turn, divided into 6 equal parts. And so if I think of my initial side on the positive x angle, then this is pi 6. That's the amount of turn. And that pi 6 is the same as 30 degrees. If I go to the next one, thinking if I started at 0 and rotated through 2 of these, this is 2 pi 6. Oh, but wait, that reduces. That's your pi thirds, which we'd already studied in this last one. So if you go through 30 degrees and then to another 30 degrees, you're at 60 degrees. And so that pi thirds is 60 degrees. These are all ones that you're going to want to know. And then straight up, this is 3 sets of pi 6. Oh, wait, that reduces to pi halves. So pi is a half turn. And you take half of a half, you get a fourth. Pi halves is a quarter of a turn. And pi halves is the same as 90 degrees. If we continue to another 30 degrees, then right here we have 4 sets of pi of 6, and that reduces to 2 pi thirds. And we had that in the last one. 2 pi thirds is the same as 120 degrees, 2 sets of 60. So 2 sets of 60 is 4 sets of 30. That should make sense. And then if we go through 5 pi 6, that's 5 sets of 30 degrees. That's 150 degrees. And then right here we would be at 6 pi 6, and this would be at pi, or 180 degrees. And then we can do the exact same thing with the bottom half. Go straight down. Try to divide those into thirds as best as you can. It's not perfect. And so this would be 7 pi 6, which is 210 degrees. This would be 8 pi 6, but wait, that reduces to 4 pi thirds. 8 sets. Oops. 8 sets of 30 is 240 degrees, and that's 4 sets of 60. 4 times 6 is 24, 240 degrees. Straight down, it would be 9 pi sixths, and that reduces to 3 pi halves. And pi halves is 90, so now we're 3 sets of 90. This is 270 degrees, or 9 sets of 30 degrees. 9 times 30 is 270. Another 30 degrees, we are at 10 pi over 6, which is 5 pi thirds. And so that is 300 degrees. And another set will be at 11 pi 6, 1 pi 6 short of a full rotation. Remember, 2 pi is a full rotation, which would be 12 pi 6. And this is 30 degrees short of 360. This is 330 degrees. Now, yeah, I'm taking some time with these, but these are ones that you're going to want to just know. So on this last one, I'm just going to go ahead and just talk about dividing it in fourths, which I kind of divide it in fourths, which this is pi halves, this is pi, this is 3 sets of pi halves, and then this is 0 or 2 pi. And so there's your 90 degrees is pi halves, pi is 180 degrees, 3 pi halves is 270 degrees, and then we get to either 360 degrees or 0 degrees. And so with degrees, you need to have the degree symbol because you've got radians now, which are real numbers. And with radians, we won't put a degree symbol, and there's a big difference. Think half of a turn is 180 degrees versus pi radians is about 3.14 radians. You have to put degree symbols on those to make those work. All right, so going through this then, I did 30s and 60s, I did 90s, but we didn't do where we cut each quadrant in half and use 45 degrees. And so if I have 45 degrees, really what I'm doing is I'm taking half a turn and dividing it into 4 equal parts. So 45 degrees is 1 pi fourth. 90 degrees is 2 pi fourths, which reduces to pi halves. And 135 is 3 pi fourths. It's 3 sets of 45 degree. And then pi is your 4 pi fourths. 225 is 5 pi fourths. Then 270 is 6 pi fourths. That reduces to 3 pi halves.